Hello students, I am Sachitrakar. Welcome to Cars Physics. This is my lecture 6 on kinematics and we are continuing motion in a straight line. As we have discussed before, in this lecture we will discuss about the last two parameters of kinematics and those parameters are acceleration and jerk. Okay, let's start from acceleration. Acceleration, we may take symbol of acceleration A and it's a vector quantity. We will discuss it in our discussion. Okay. Then before going to discussion on acceleration, let's first think about velocity. Velocity is defined as the rate of change of position vector, or simply we may say velocity is defined as rate of change of displacement. Okay. So when position vector changes or displacement changes with respect to rate means time. When position vector changes or displacement changes with respect to time, then velocity is produced. Okay. So when velocity changes, then we may say acceleration is produced. When displacement changes, velocity is produced. And when velocity changes, then acceleration is produced. Let's discuss about this. Suppose a body is in one-dimensional motion. Let a body is moving along x-axis. Initially, it starts its motion from origin O when time is 0 and its position is obviously 0. Value of x is 0. The body continues its motion along x-axis. Let at any instant t1, the body is at position A. At time t2, the body reaches at B. Okay. Then position vector of position A for position A. Position vector, let here we may take OA vector. From O to A directed along x-axis, we may take it x1. Okay. 0 to x1, that is OA. Similarly, for position B, position vector may be taken as OB and that's equals to x2 along x-axis. So, position vector changes from x1 to x2 and time changes from t1 to t2. Thus, velocity is rate of change of position vector, or we may write it, velocity is rate of change of position vector, change in position vector x2 minus x1, change in time t2 minus t1. So x2 is OB, x1 is OA. So simply speaking, this is equals to change in displacement from A to B, that's equals to S. We may take S upon time, means time is interval of time t2 minus t1 is t. So here velocity changes due to change in displacement or due to change in position vector. Okay. Rate of change of means with interval of time. Okay. So we may say in simpler way, acceleration is produced whenever there is change in velocity. Okay. Velocity is produced when displacement changes. Acceleration is produced when velocity changes. In very simpler way. Okay. When the body reaches at A, at the instant of time t1, the velocity of the body is v1, and when it reaches at position B, at the instant of time t2, velocity is v2. Okay. Thus, velocity changes with respect to time, means velocity changes from v1 to v2. Okay. During this change in velocity, time increased from t1 to t2. Okay. So velocity changes with respect to time, or we may say velocity changes with respect to position. Okay. Position changes from x1 to x2 and accordingly velocity changes from v1 to v2. Of course here velocity changes due to only change in magnitude because direction of velocity is constant, that's along x-axis. So acceleration may be calculated by considering change in velocity with respect to time, okay, or change in velocity with respect to displacement. Okay, these are two ways to calculate acceleration. Then we will find in which way we can calculate acceleration more easily. See students, in this subject means under motion in a straight line, we will go through kinematics equations as we have discussed. Okay, all those equations you know, or you have already gone through these equations from your pre-standard. That's v is equal to u plus at, b square is equal to u square plus 2as. B is final velocity, u is initial velocity, t is interval of time, s is displacement. All these things you have already gone through it. Again, in this subject we will know how to derive those equations and how to use those equations to solve numericals. Okay. Then finally, we may say acceleration is produced due to change in velocity. Okay. Acceleration may be calculated taking our consideration change in velocity with respect to change in time, or change in velocity with respect to change in displacement, or with respect to change in position. Okay. Then which way is easier? Okay. If we consider acceleration is constant, the best example of constant acceleration is acceleration due to gravity at a given place. Okay. At a given place, acceleration due to gravity means in space is constant but up to a certain height. What's the consideration? If height above the surface of Earth, this is Earth's surface. If height above the surface of Earth, let h, is much less as compared to radius of Earth, then acceleration due to gravity may be taken to be constant quantity, or acceleration due to gravity is uniform. Means acceleration is uniform up to a certain height, which is very small as compared to radius of Earth. Radius of Earth is 6400 kilometers. If height above the surface of Earth is less than 6400 kilometers, then we may consider acceleration due to gravity or acceleration in space always remains constant. It is always directed in vertically downward direction, straight in downward direction, and the standard value of acceleration due to gravity is 9.8 meter per second square, as you know. Okay, in MKs, and 980 centimeter per second square in CGS, and 32 foot per second square in FPS. Okay, we'll analyze in which way we can calculate acceleration easily. Okay, let's consider a body is dropped from a height. I am holding the body, I will release the body. When I am holding the body, the velocity of the body is 0. If I release the body, then the body will start its motion when initial velocity is 0. That's when time is 0. I release the body. Then the body will move in vertical downward direction. Acceleration on the body is g, means acceleration due to gravity. Let's consider interval of time. This is the position of the body when time is 1 second. This is the position of the body when time is 2 seconds. This is position of the body when time is 3 seconds, and so on. Okay, I have taken up to this. Okay, then we use in this case the equation v is equal to u plus at. Here acceleration is due to gravity, means in vertically downward direction. Okay, we will go through equation in later stage in this subject. Okay, then here initial velocity, let this is position A, this is position B, this is position C, this is position B. Initial velocity at position A is 0 when time is 0. When it reaches at B, let its velocity becomes v1, then v1 is equal to u is 0 plus g, time taken, means here interval of time is from 0 to 1 second, means time is 1, means velocity is equal to g. Okay, if you put value of g, then magnitude of velocity, direction is vertically downward, magnitude of velocity is 9.8 meter per second. Then it's the velocity when the body is at B. Similarly, when the body reaches at C, let the velocity is v2 at position C, magnitude of velocity v2. v2 is equal to u plus gt. Time taken by the body to move from A to C is 2 seconds, then g into 2 seconds, that's equals to 2g. I am writing in this way. Here velocity is v1g, here velocity v2 is 2g, magnitude, direction in vertically downward direction. Similarly, when the body reaches at D, position D, let's its velocity becomes v3. Okay, then v3, magnitude of v3, initial velocity is 0, plus in place of a we may take g into 3, that's equals to 3g. See students, in very easier way we can calculate velocity. v1 is equal to g, v2 is equal to 2g, v3 is equal to 3g, and so on. So acceleration in this case, acceleration is uniform or constant. So here acceleration means acceleration of the body. We may calculate g using all these. Okay. So v2 minus v1 means here from A to B, v1 minus 0. Suppose I am writing it A. What's acceleration? We have to calculate. Let's take acceleration is rate of change of velocity, means the ratio of change in velocity to change in time. Okay. Between A and B, from A to B, we have to calculate acceleration. Change in velocity is v1 minus u, u is 0, divided by change in time, 1 minus 0. So acceleration is v1, v1 is g. Okay. Then from B to C, okay. Again we have to calculate acceleration. Change in velocity means v2 minus v1 divided by interval of time. When the body reaches at C, time is 2 seconds. When the body reaches at B, time is 1 second. So interval of time is 2 minus 1. So here acceleration is v2. v2 is 2g minus g divided by 1. Again acceleration is g. Okay. So this is the way. This is the only demonstration how to understand acceleration. Okay. This is the way how to calculate acceleration using the definition. Acceleration is rate of change of velocity, means change in velocity with respect to change in time. Okay. So here to calculate velocity at different positions is easier. So we can calculate acceleration in easier way, because change in velocity divided by change in time. If calculation of velocity is made easier, then calculation of acceleration will also be made easier. Okay. Then calculating acceleration with respect to distance. The similar way, let a body is dropped from a height. Here initial velocity is 0, position is A, time is 0. Okay. This is next position, let this position is B. This is next position, let position is C, and so on. Okay. We'll take up to from A to B and then from B to C. Also you may take from C to D and so on. Okay. Now we will use the equation V square is equal to U square plus 2AS. Here U is 0, initial velocity 0. So V is square root of 2AS. So here acceleration of the body may be taken as due to gravity. So we may take formula for velocity is root of 2g. S in place of h we can write h because the body is moving in vertically downward direction in space. Okay. When the body reaches at position B, let its velocity become v1 as we have taken before. Okay. Here let height is h. From A to B means displacement from A to B is h. So here if you take h is equal to 1 meter for each equal displacement. So here h is 1 meter, here also displacement h is 1 meter, here also displacement h is 1 meter. From A to B, vertical displacement 1 meter, from B to C, vertical displacement 1 meter, again from C to D, vertical displacement is 1 meter. Then from A to B, velocity at position B is v1. Okay, square root of 2gh, h is 1 meter, so v1 is square root of 2g. From B to C, okay, from B to C, when the body moves from B to C, here final velocity is v2. Okay, final velocity is v2, but body has moved from A to C, so v2 is equal to square root of 2g, but here distance travel or displacement of the body is from A to C, 1 meter plus 1 meter is 2 meter. So this will come √2 times of square root of 2g. Then from C to D, if you take from C to D, see students, I am writing here from C to D, to reach at position D, total displacement of the body in vertically downward direction is 1 meter plus 1 meter plus 1 meter means 3 meter. Okay, then let at position D, velocity of the body is v3, then v3 is equal to square root of 2g, h here is 3 meter, so v3 comes √3 times of square root of 2g. See students, here v1 is square root of 2g, v2 is √2 times of √2g means v2 is equal to, you may write here, v2 is equal to √2 times of v1, similarly v3 is √3 times of v1. So see students, to calculate here change in velocity is some extent will be lengthier as compared to calculate velocity in this case 2g, 3g and so on. But here √2 times, √3 times. So if we calculate velocity in easier way, then we can calculate acceleration in easier way. So better method to calculate acceleration is we have to take change in velocity with respect to change in time v1 to v2 with respect to change in time v1 to v2. Change in velocity, final velocity minus initial velocity divided by change in time. So it's the easier way. Okay. This method means to calculate acceleration in easier way is found from long before by the great scientist Galileo. So this is the easier way to calculate acceleration. Means finally we may define acceleration. I think you have understood all these things, considering interval of time, considering change in positions or displacements. Okay. Then we will now go to our general studies. Okay. In general way, now we will accept the definition of acceleration as acceleration is defined as the rate of change of velocity. When velocity changes, acceleration is produced. Acceleration is defined as the rate of change of velocity, means the ratio of change in velocity to change in time. So in simpler way, you may write acceleration for average acceleration, change in velocity delta v, change in time delta t. Okay. So acceleration is a vector quantity. Change in velocity, velocity is vector, change in velocity is vector, so acceleration is vector. Then what's direction of acceleration? From the equation you may say direction of acceleration is along the direction of change in velocity. But the simpler way, when does velocity change? Velocity changes due to application of external resultant force according to Newton's law. Okay. Again you know force is equal to mass into acceleration. So direction of acceleration, very simpler way. Direction of acceleration is along the direction of external resultant force. Okay. Mass has no direction, so direction of acceleration is along the direction of external resultant force. This is easier way. Then acceleration is vector quantity. Then units, you know all these things. These are only two formal discussion. Change in velocity, meter per second. Change in time second, so this is equals to meter per second square, or in CGS centimeter per second square, in FPS foot per second square. And this is about units. Then dimensional formula of acceleration, meter is length, second is time. So mass to the power 0, meter, length to the power 1, and time to the power -2. Okay. So this is about definition of acceleration. Okay. We'll analyze the complete form of acceleration. Okay. Then types of acceleration. As usual form, types of velocity, types of acceleration. All are in similar form. Number one, a bit uniform acceleration. Okay. Acceleration is defined as rate of change of velocity. Okay. In similar way, we may define acceleration is uniform if velocity changes equally. If velocity changes equally in equal interval of time. Recall, what is uniform velocity? Velocity is uniform if displacement changes equally in equal interval of time. Here we may say acceleration is uniform if velocity changes equally with equal interval of time. Okay. Let's discuss. A body is moving along a straight line. Okay. Starts from here. Let position is O when time is 0. Okay. Here at position A, time is 1 second, means interval of time to move from O to A is 1 second. Body is moving with acceleration. Let at position A, velocity of the body is V1. Okay. Here velocity of the body is 0. Okay. Then change in velocity. Suppose I am taking this velocity is any value you may take. Let this value is 5 meter per second. Okay. Then from O to A, acceleration from O to A, change in velocity 5 meter per second, initial velocity 0, divided by change in time t minus 0 means 1 minus 0. So acceleration is 5 meter per second square. Means here velocity changes by 5 meter per second from O to A. Similarly, this is suppose position B. Okay. Let here velocity of the body becomes V2. Okay. Equal change in velocity in equal interval of time. You may take here time is 2 seconds and velocity is 10 meter per second. Then from A to B, again acceleration is a change in velocity 10 meter per second minus 5 meter per second divided by change in time 2 minus 1. Again it comes 5 meter per second square and so on. So velocity changes equal 5 meter per second. Here also change in velocity 5 meter per second, 10 meter per second minus 5 meter per second. Because the body is moving along a given direction, so you may calculate magnitude of change in velocity directly by subtracting initial value from final value as per laws of vector addition. Okay. So velocity changes equal 5 meter per second, 5 meter per second, equal interval of time from O to A 1 second, from A to B, again time interval is 1 second. If velocity changes equally with equal interval of time, then acceleration is uniform. Okay. Then number 2 means B bit non-uniform acceleration. Non-uniform acceleration, or we may say this is variable acceleration. Acceleration varies. Okay. Say again, in similar way as that we have discussed in velocity, acceleration is non-uniform or acceleration is variable if velocity changes unequally. If velocity changes unequally with equal interval of time, then acceleration is non-uniform or acceleration is variable. Let when the body reaches at position A, velocity is 5 meter per second. From initial position O, velocity is 0. Okay. Time taken by the body to move from O to A is 0 to 1 second. Means interval of time is 1 second. Okay. So from O to A, acceleration is again the same thing. Change in velocity 5 minus 0 divided by change in time 1 minus 0. So this is from O to A. Acceleration is 5 meter per second square. But when the body moves from A to B, let here velocity becomes 15 meter per second. Then from A to B, acceleration change in velocity 15 meter per second minus 5 meter per second divided by 2 second minus 1 second. So acceleration comes 10 meter per second square. If you consider another position, let this position is C. Suppose at position C, time t is 3 seconds equal interval of time. From 1 second to 2 second, 1 second. From 2 second to 3 second, again interval of time is 1 second. Let here velocity is v3, which is equals to 30 meter per second, or you may take velocity decreases, okay, 10 meter per second, whatever you may take. This is 30 meter per second. Then from B to C, acceleration is change in velocity 30 meter per second minus 15 meter per second divided by change in time 3 second minus 2 second. Okay, then here acceleration comes 15 meter per second square. So velocity changes unequally with equal interval of time, then we may say acceleration is non-uniform or acceleration is variable. I have taken equal interval of time. Why? We have already discussed in previous lectures. Okay, so this is about non-uniform acceleration. Okay, then next point, next type of acceleration, see, average acceleration. As we have discussed, average speed, average velocity, here also the similar type of discussion, average acceleration. If a body moves with non-uniform acceleration, then we have to calculate average acceleration. Average acceleration, it is defined as the total change in velocity, the ratio of total change in velocity. Let final velocity is v2, initial velocity is v1, final time is t2, initial time is t1. Then average acceleration is defined as the ratio of total change in velocity to total change in time. We may write it as delta v divided by delta t. Okay, no need to analyze more because you have already know about average form of speed or average form of velocity. Then finally, instantaneous acceleration. Instantaneous acceleration. Again, we may define it in similar way. Instantaneous acceleration is acceleration at any instant of time as that of in case of velocity. Okay, instantaneous velocity is velocity at any instant of time. Okay, instantaneous acceleration is defined as acceleration at any instant of time. We have discussed in brief in previous lecture. Means when we are considering or when we are discussing about speed and velocity, instantaneous time means that interval of time is very, very small, not zero, nearly zero, very small, approaching zero. Okay, then I may advise you, please go through the previous lectures and about instantaneous velocity, instantaneous speed. Your concept will be completely cleared up, and accordingly you can understand instantaneous acceleration. Okay, instantaneous acceleration. Instantaneous acceleration is acceleration at any instant of time, and in similar way we may conclude instantaneous acceleration is calculated by the limiting value of what? Limiting value of time. Limit of time is too small. Okay, very small, not zero, approaching zero. Nearly equals to zero, a fraction of time. Instantaneous acceleration is calculated by the limiting value of average acceleration. Instantaneous acceleration is calculated by, first we have discussed about qualitative definition of instantaneous acceleration. It's the acceleration at any instant of time. Again, for quantitative form, instantaneous acceleration is calculated by limiting value. Limiting value of interval of time which is very, very small, limit delta t tends to zero of average acceleration. Limiting value of average acceleration. Average acceleration is delta v divided by delta t. Okay, and the answer is dv by dt. Again, we can calculate instantaneous acceleration by using differentiation as that of in case of velocity or speed. Okay, dv by dt. Okay, this is about types of acceleration. Okay. Now some discussions on acceleration. These are regular studies. Okay. Then some analysis. Okay. First thing, my dear students, direction of acceleration is along the direction of force. Okay. Suppose acceleration, a body is moving along a straight line, then magnitude of acceleration is change in velocity, final velocity minus initial velocity divided by change in time, t2 minus t1. Okay. See students, when a vehicle or when a body moves, it doesn't mean that its acceleration always remains same, means velocity change equally. Velocity may increase or velocity may decrease. Okay. Suppose you are moving by your two-wheeler. All the students are using two-wheeler, scooty. Okay. You are traveling on a road. If some marketplace comes, then you have to slow down your motion. Okay. If you get some free road, then you have to accelerate your vehicle. Accelerate. Simply rotate it. Okay. Then acceleration, and to decrease, you are using again the same rotation but in different order. That's called as retardation. Velocity increases, acceleration. Velocity decreases, retardation, or we may say deceleration. Okay. If velocity of a body increases, okay, final velocity, if magnitude of final velocity is less than initial velocity, v is less than u, then acceleration is negative. This is called as retardation or deceleration. How velocity is decreased? Okay. Suppose you are moving. You observe that some dogs are fighting on the road. Immediately you will apply your brakes. Then brake applies the force in opposite direction to that of your motion. So if force is applied along the direction of motion, then velocity increases. If force is applied opposite to the direction of motion, then velocity is decreased. Okay. So here acceleration is negative if v is less than u. Similarly, if velocity increases by using acceleration, accelerator. Okay. If v is greater than u, then obviously v minus u will be positive. So acceleration is positive. So this is positive acceleration, negative acceleration. Negative acceleration is called as retardation or deceleration. Okay. Next. In usual form, we may discuss acceleration is a vector quantity. Acceleration has both magnitude and direction. Okay, as that of in case of velocity. So acceleration is acceleration changes due to only change in magnitude, or due to only change in direction, or due to only change in or due to change in both. Okay. Then acceleration is defined as rate of change of velocity. Okay. Means when velocity changes with respect to time, we do calculate acceleration. In similar way, we may say velocity changes with either change in magnitude or change in direction or change in both. Okay. Suppose a body is moving along a straight line. This is the motion of the body at any instant of time t. Body is at this position, moving with a velocity let u. Okay. To increase the velocity, means to increase magnitude of velocity, the force applied along the direction of motion, then velocity will increase. If force is applied opposite to the direction of motion, this is the direction of motion. If force is applied opposite to the direction of motion, then velocity will decrease. Okay. Thus, to increase, very important, formal discussion, to increase or to decrease the magnitude of velocity or speed. Speed is magnitude of velocity. As you know, velocity is defined as speed in a given direction. Okay. To decrease, either to increase or to decrease the magnitude of velocity, force must be either parallel or anti-parallel to the direction of motion. To increase or to decrease speed of a body or magnitude of velocity, to increase the speed, force must be applied along the direction of motion. To decrease the speed, force must be applied opposite to the direction of motion. Okay. Suppose a body is moving along x-axis. Now we do want to change its direction. Okay. I am showing here. A body is moving along x-axis. This is the direction of velocity. Okay. I want to change the direction of motion. Then I have to apply force perpendicular to the direction of motion. Okay. As you know, from vector analysis, a vector has no component at an angle 90 degree to its direction. Means this force has no component either along velocity, direction of velocity, or opposite to the direction of velocity, because force, direction of force makes an angle 90 degree along the direction of motion or opposite to the direction of motion. Thus this applied force can never change magnitude of velocity. As we know, to change magnitude of velocity, we have to apply force either parallel or anti-parallel to the direction of velocity. Here this force has no component either parallel or anti-parallel to the direction of velocity. So this force only changes the direction of velocity, means direction of motion. So our conclusion, to change direction of velocity, force must be perpendicular to the direction of motion. Okay. Suppose someone asked me, can force necessarily be perpendicular? Applied force can necessarily be perpendicular to the direction of motion? May not be. How? Suppose a body is moving along this direction, this is direction of velocity. Okay. Suppose a force is applied along this direction. This is force, making an angle theta with the direction of velocity. So this force has component along the direction of velocity, that's equal to f cos theta. And perpendicular to the direction of velocity, this force is horizontal. This force component of velocity perpendicular to the direction of motion is f sin theta. F cos theta. Okay. F cos theta is responsible. F cos theta is along the direction of motion. F cos theta is responsible to increase the magnitude of velocity. F sin theta is responsible to change the direction of velocity. Okay. If both magnitude and direction of velocity change, then there must be the forces either along or opposite to the direction of velocity, and another force must be perpendicular to the direction of velocity so as to change the direction of motion. We'll analyze it. Okay. Let's take example. Can I erase it? You should take screenshot. Okay. 1, 2, 3, 4. We go through two-dimensional motion. Later stage. Okay. Suppose a body or a particle is moving along a circular path. Let speed of the particle is v. Okay. At any instant, let the particle is at position A. This is center of the circle is O. We'll know all these things. Suppose the particle is moving along the circle with uniform speed, means speed is constant. So this is called as uniform circular motion. Okay, speed is constant, speed is not changing, but velocity is changing because velocity changes with either change in magnitude, means with either change in speed or due to change in direction or due to change in both. See students, the body is moving in anti-clockwise order. This is a concept. If a body moves on a curved path, then to know direction of velocity at any instant, if a body moves along a curved path, then to know direction of velocity at any instant, at any position, we have to draw a tangent at the required position. How you will be convinced? Suppose, we have discussed, I think, a stone is tied by a string whirled in a horizontal circle. If the string breaks, then the stone will fly tangentially. So, from this point, this is the direction of tangent, means this is the direction of velocity. Let this velocity is v1, as we have discussed, I think we have discussed before. So, if this is position B, okay, then this is the direction of velocity, this velocity is v2. This is position C, this is the direction of velocity v3, but speed is constant. So here, velocity changes, means v1 vector is not equals to v2 vector, is not equals to v3 vector, but v1 magnitude is equal to v2 magnitude is equal to v3 magnitude and so on, that's equals to v, means speed is constant. Here, velocity changes due to only change in direction, so here the force must be perpendicular to the direction of velocity. This is direction of force, so force is equal to mass into acceleration, so this is also direction of acceleration. Here also, this is the direction of acceleration perpendicular to velocity, here this is direction of acceleration perpendicular to velocity. Here acceleration is not uniform, magnitude of acceleration may be uniform, as we will discuss in two-dimensional motion, but direction of acceleration changes. Okay, but overall we may say when direction of velocity changes, acceleration is perpendicular to velocity or force is perpendicular to velocity. Okay, this is the case of uniform circular motion. If we consider non-uniform, I am writing here non-uniform circular motion. For non-uniform circular, what's meant by non-uniform circular motion? Uniform circular motion, if a body or particle moves along a circle with uniform speed. Means in uniform circular motion, speed remains constant, but velocity doesn't remain constant, velocity changes due to change in direction. Okay. In non-uniform circular motion, speed of the body moving along a circle doesn't remain constant. Means in non-uniform circular motion, velocity changes due to change in both magnitude and direction. If a body moves along a curved path, obviously direction will change. Again, non-uniform means speed doesn't remain constant, as we have discussed. To change the speed, force must be applied either parallel, I am considering this velocity v1, force must be applied either parallel or anti-parallel to direction of velocity. So, acceleration may be along the direction of velocity or opposite to the direction, means anti-parallel to the direction of velocity. Okay. So for non-uniform circular motion, means when magnitude of velocity changes due to change in when velocity changes due to change in both magnitude and direction, there must be two components of velocity, two components of acceleration. I am writing here. Here, velocity changes due to change in both magnitude and direction. Let magnitude of velocity increases. So to increase the velocity, acceleration must be parallel. Again, to change the direction, acceleration must be perpendicular. So this acceleration is called as tangential acceleration. It is along the tangent, and this acceleration is called as radial acceleration. Okay. So to change both magnitude and direction of velocity, there will be two components of resultant acceleration. See students, angle between tangential and radial acceleration is 90 degree. We may take this is resulting acceleration. Okay, from vector diagram we can calculate angle between them is 90 degree. Then resultant acceleration is vector sum of radial acceleration plus tangential acceleration. Okay, we'll discuss in brief in motion on a plane. So, if both magnitude and direction of velocity change, then acceleration, resulting acceleration has two components, rectangular components, radial acceleration and tangential acceleration. Okay. Then some other discussions related to this type of motion. See, acceleration is defined as rate of change of velocity. So, if I write magnitude of dv by dt, so it's equals to magnitude of acceleration. Okay, dv by dt is acceleration, magnitude of dv by dt is magnitude of acceleration. Okay, but if I write d by dt of speed, v is speed, then it is rate of change of speed. Here it is rate of change of velocity. Okay, means magnitude of acceleration is magnitude of rate of change of velocity. Here also rate of change of speed. When speed changes means magnitude changes, acceleration is produced. So this is also magnitude of acceleration. But the ways are different. Here acceleration is produced due to only change in speed. Here acceleration is produced due to change in velocity, means due to change in both. Okay. Here magnitude and direction both may change, or only due to change in direction acceleration may be produced. Due to change in direction, acceleration is radial. Due to change in magnitude, acceleration is tangential. Okay. So in uniform circular motion, I may write in some other place. In uniform circular motion, in uniform circular motion, in uniform circular motion, speed is constant. Okay. Then in uniform circular motion, d by dt of speed is 0, because derivative of differentiation of any constant is 0. Okay. So in uniform circular motion, speed is constant, so rate of change of speed is 0. Okay. But in uniform, so if we consider in non-uniform circular motion, non-uniform circular motion, in non-uniform circular motion, d by dt means rate of change of speed is not 0, because in non-uniform circular motion speed changes. Okay. Then can I erase all these things we have already discussed? Okay. For uniform circular motion, speed is constant. For non-uniform circular motion, speed is not constant. So rate of change of speed is 0 for uniform circular motion. Rate of speed and change of speed is not 0 for non-uniform circular motion. Okay. This is about uniform and non-uniform circular motion. Okay. We will discuss it in later stage. Then final point about acceleration. Acceleration is defined as rate of change of velocity. Okay. Again I can write acceleration is d by dt of v, velocity is ds by dt. Okay. Then finally I can write acceleration d by dt square of displacement dt not d square t square, dt is interval of time, dt square. Okay. Then this is about acceleration d square by dt square is equal to obvious displacement is acceleration. So sometimes question is asked why time is stated twice. Why time is stated twice in acceleration? This is your answer. There is square form of time. So acceleration is expressed as meter per second square, displacement square of time or centimeter per second square. Again, another form, acceleration is equal to dv by dt. We may write acceleration is d by dt of v in place of dv, okay, dv into, suppose I write ds by ds, okay, then acceleration is dv by ds, again ds by dt. Finally, I can write ds by dt is v, again dv by ds. V dv by ds in terms of displacement. Okay, we can use it when we will go to numericals. Okay, then final point about non-uniform acceleration. I am erasing all these things. Very important point. If a body moves with acceleration a1 for interval of time t1 and moves with acceleration a2 for interval of time t2, then average acceleration is given as a1 t1 plus a2 t2 divided by t1 t2, t1 plus t2. Very important for application of problems in any competitive exams, NEET, JEE, etc. Okay, so this is the formal definition about acceleration and some conceptual points also included. Okay, this is end of lecture 6. Okay, in next lecture, means in lecture 7, as that of in previous lectures we have done, we'll discuss only some numericals on acceleration. Sorry, another point is there. This is about acceleration, and final parameter is jerk. Jerk, or you may write it jolt. See students, jerk or jolt is not in our scope. Means we will not have to face any question related to jerk. Okay, just you should have a fundamental idea. Jerk. Jerk is defined as the rate of change of acceleration. See students, when velocity changes with respect to time, we do say acceleration is produced. When acceleration changes with respect to time, then we do say jerk is produced. So jerk is defined as rate of change of acceleration dA by dt. Obviously, its units are acceleration meter per second square, dt is in second time, so you may write meter per second cube or centimeter per second cube, and accordingly dimensional formula, meter length m to the power 0, meter length m to the power 1 divided by second cube means time cube t to the power minus 3. Okay, in next lecture we'll discuss some numericals based on acceleration. Thank you students and my young friends for your great support and inspiration. Be with me, be a part of this new journey. Thanks all.